Good morning, grade 10s. This is the second drawing that we are doing from orthographic to isometric. As you can see, in this case, I am using colors, and by using the colors, I'm trying to show you the different surfaces for the different views. So again, the important thing is to read the question. The figure shows the three views of a shaped block drawn in third angle orthographic projection. Convert the orthographic views into an isometric drawing. Make A the lowest point of the drawing, and you do not have to do any dimensioning. So again, if I just quickly show you the 3D model on the right hand side, that is the left view, that is the front view, and that is the top view. I don't really want to show you the answer yet, but you could have a few glimpses as I am swinging this around for you to see what's happening. Again, like in the drawing that I've done before, is remember what I said, every solid line that you see is a change of direction and a change of height. So again, in this specific question now, remember we're drawing the front, top, and left in this case. So if we go into the isometric drawing itself here, with A as my lowest point, if I look in this direction, that will be the front view. If I look in this direction, that will be the left view. And if I look from the top, that will be the top view. So if I look at my question itself, that there will be the first shape that I draw. So if I look at the width here, that's 60, that's 15 for that height, and the height for that one there is 45. So if I then start drawing, I can go here, and that distance there, remember we said that that is 60. Then we're going to go 45 millimeters up. The thickness there is 15. Then remember now coming down, 45 minus 50, that will be 30. 15 of 60 gives us 45, and there is the first surface drawn. Now immediately, like I said to you, there's so many different ways of drawing isometric. I just found through the years that this is the easiest method that I can think of. So if we now look at what we've got here, we are now at that surface there. So that surface there now, if I compare it to my other two views, I can now see it is that rectangular surface there and that rectangular surface there. So how far does it go back? It goes 20 back and that surface there. So now I can go from there, 20 millimeters back. That's 15 wide and 20 millimeters back. So now I've done that part. The next one that I want to do is that one going straight up, which is that one there. So now that's a total of 70. So 5 of 70. So that will give me another, 25. So I now start from here. 45 to 50 is 5. 50 to 70, so it's 25 extra. That is 15. And then we go down. So again, I can now make that dark. Okay. If I now look at the top surface here, that is 30 going back, and that gives me all of that information at the top. So again, I can now go from there, 30 millimeters back, and 15, and 30 millimeters back. Okay, so that is the information that I've been given between the front view and the top view. I can now do exactly the same using the left view. So again, that's 15 up, that's 25 high, that's 15 wide. So again, I can now go from here, start on that corner. Oops, I must just start on the right corner, otherwise these things are not going to line up properly. That distance there, the width is 50. The height in this case is 25. Then that is 15. The difference between 25 and 15 is 10. So that means this here closes down. Very nicely. So immediately, that is already information that I can draw. So if I now look, there's the shape that I now got to follow. So if I look at that, that's now where that 45 comes in again. So that distance, how far is that? That's 60, so that's 20 back. So now I can go from here in that direction, 20 millimeters back, 15 wide, 20 millimeters. I can make that dark. Okay, now how far does it go up? Remember we said that's at 45 because those two are in line. So now that being 25 high, that means that this must go another 20, 15, that's the width for that. Okay, and then this one now goes the last bit, 15 off. Okay, remember now that's 40. Now I just got to do my sums here properly because I know that one I can do it that way too. So instead of doing the sums, as you have just heard, my mathematics is not as good as it should be. So there we go. Okay, and the last few lines that I need to insert, that one goes to the top, this one goes backwards, this one goes down, this one goes backwards, and look at that, we have now got our answer. As quick as that. And like I say, and I'll say it again, doesn't matter which direction we go. There are so many different methods of doing an isometric drawing. But now I just want to show you that the answer is correct. So again, we're looking at the front view. So if we look at what I'm showing you there and the 3D, between the 3D model and the isometric, those two look exactly the same. Okay, if we look at the left view, that left view, all of that information look the same as well as the top view. And if I then want to do the last bit to make sure that you guys agree with me, that is top view, that is top view, that is top view, that is top view, that is top view. So if I say match this property to these, they are now the same. So those surfaces are all at different levels, and that is what that looks like. My front view, I've got to put the hatching in first. The hatching is front view, and front view. So again, I can match that there to there. You can now see that that L bend is there, that surface is there, that surface is there. And then the last one is for the left view, which is this one, and this one. And if I go and match that they look the same color, that is what we see. So again, that surface there is that surface there. This surface here is this surface here. And this surface here is that surface there. Okay, I hope that that has cleared any questions that you might have on isometric drawings.